Hello and welcome. Today we'll start the unit of geometry and trigonometry. Our first lesson is on Introduction to Similar Triangles. These two beautiful discs have the exact same shape, the same number of petals have the same shape, but they're different in sizes. We say that these are two similar shapes. We use this symbol to indicate similarity. In mathematics, we say that polygons are similar if their corresponding or matching angles are equal. That's because angles are what give polygons the shape. In the meantime, the ratios of their corresponding sides are in proportion, which means that the ratio of the size of this petal in here over this petal in here must be the same as the ratio of this petal over this one. Now, we say that polygons are congruent if they have the exact same angles, so the matching angles are the same, so they must have the same shape. But the ratios of the corresponding sides are in proportion 1 to 1, which means same size. So here goes the first theorem on proving similarity in triangles. To show that two triangles are similar, it's sufficient to show that either two angles of one triangle are congruent or equal to the two angles of the other triangle, or the ratios of their corresponding sides are in proportion. So here goes our first example. So in this example, we are given the triangle ABC, and the sides of triangle ABC are 6, 7, and 10. Now, the other triangle DEF has the sides respectively 12, 14, and 20. We are going to say that since we see the same symbols at each angle, then the angles are equal. That tells us that the two triangles have the same shape. So to prove, though, that the two triangles are similar, we're going to say that we need to prove that the ratios of their respective sides are equal. So this is the way we want to prove similarity, and please listen carefully to this. I always start by writing the first triangle, and the order won't really matter. But I usually tend to follow the alphabetical order because it just makes more sense to say triangle ABC than triangle BCA. So I would say that the triangle ABC is similar to triangle, and now I'm going to be careful. So if I started with angle A in naming the triangle ABC, then I will start with triangle DF. I'm going to start with the angle that is equal to angle A. So angle A is equal to angle D. So what that means is that I'm going to start here with D. The next angle is angle B. So angle B is equal to angle E. So therefore, my next angle in the triangle DEF must be angle E. Last but not least is angle C. So for angle C, we are going to say that angle C equals angle F. So therefore, the last angle that I want to write in here is the angle F. So in other words, we're going to say triangle ABC is similar to triangle DEF. Let me make this point clear here. Okay? So why do we want to do this? It makes it a lot easier for us to prove the similarity or to write the ratios of the similar triangles. So, and this is the order we follow. So we go AB over DE, so the sides that are formed by connecting the two angles that are equal to each other, must equal BC over EF and then must equal, the last one will be AC and DF. Now we are going to take a look at their lengths. So the length of AB is 10, the length of DE is 20. So that means we have 10 over 20 equals, for BC we have 6 and EF 12, so 6 over 12. And for AC we have 7, for DF, for DF we have 14, so that's 7 over 14. So we're going to say that 10 over 20 is 1 over 2, 6 over 12 is 1 over 2, and 7 over 14 is 1 over 2, which tells us that the sides of triangle DEF are twice as big as the sides of the triangle ABC. And with this, we have proved that these two triangles are similar. There is a second theorem on the geometry of two triangles or two similar triangles. It states that the area of a triangle ABC and over DEF, if ABC and DEF were two similar triangles, okay, that's a condition they must satisfy, then the ratios of the squares of the respective sides are equal. So here we go. We have another example here. We have the triangle ABC and DEF. I'm going to draw them. I'm going to try my best here. Okay, so here goes the triangle ABC. I'm going to draw the triangle DEF, and it looks like DEF is a little bigger, so let me try. Okay, so that's good enough, I would say. So here we go, DEF. And again, you see how we have in here ABC. So we have A, that means, and then D. So A and D must be equal to each other, which means that we have to write angle D right here. Now, angles B and E must equal each other, which means that if this is B, E must go right here. And the last one would be the angle F. So F must be right here because it equals angle C. And to show that the respective angles are equal, we use these symbols. So one line for angles A and D, which are equal. Two lines for the angles B and E, which are equal. And 3 lines for the angles F and C, which are equal. Okay. Now, if the triangle ABC has one side that is 8 centimeters and DE is 12 centimeters, so it tells us that the ratios of the sides are 8 to 12. It's given that they are similar, so we're going to say that the area of the triangle ABC divided by the area of the triangle DEF equals the length of AB squared over DE squared. And that will be equal to, just substitute, we don't know the area of ABC, so that would be our unknown, so we're going to leave it as is. DEF is 54, AB is 8, must be squared, and DE is 12 squared. Further to this, area of the triangle ABC again, over 54 equals 64 over 144. By cross multiplication here, you will get area of the triangle ABC equals, and you probably remember or not how the cross multiplication works. If this is the unknown, so here is a small trick or a shortcut, I would say. So if this is your unknown, when you use cross multiplication, remember, use cross multiplication only if you have exactly one ratio in each side of the equation. Then you would have to multiply first the two lengths in here, 54 times 64 in our case. And then you have to divide by the number that is across from the unknown. Okay, that would be division because that becomes coefficient, all right? So over 144. So just use a calculator to find what 54 times 64 over 144 equals, and I'm going to use the calculator here. 54 times 64 divided by 144, that's 25.3. So we'll say that 25.3 centimeters squared will be the area of triangle ABC. Okay, so we said that it was 25.3. Okay, sorry. So 25.3 centimeter squared. And that's the answer. That's all. Okay, so now there you have some independent practice questions that you can look at if you wish. And the things that I want you to remember from this lesson is only the fact that to prove that similar triangles, when you write the similarity statement, it's important that you match the angles, right? And then from there you can build your ratios. And number two, that the ratio of the areas is equal to the ratio of the square of each side. That's it for now. See you next time.